Alright, this is Schweitzer, and we're going to do a quick little overview video on the basic stuff you need to know about solutions. Okay, and we'll try and put it in a way that you can try this out on your own, and then with me, and then maybe try it out on your own afterwards. Okay, follow-up video that'll be some mostly just problems. So these are all going to be kind of new. You're going to just kind of walk with me through this. So we have a chemical reaction here. And we want kind of know how much product we're going to get. So 100 milliliter sample of 0.5 molar NaCl. So this is 100 milliliters, and it's 0.5 moles per liter. Reacts with the 0.25 moles per liter of silver nitrate until no more silver nitrate precipitates. How much volume is required? So long answer to this thing, or a little bit longer version, would be NaCl plus AgNO3 yields NaNO3 plus AgCl. Initial stoichiometric ratio N. Now, the long way of looking at this is to determine the moles of this guy. And you should realize that this is at a 1-to-1 ratio, so equal the moles of this one. And that at that point, I could convert it to volume with this concentration. That's ultimately what I'm going to do. So molarity is equal to moles per liter, or in this case, molarity times liters equals moles. And this is often an important relationship I'm thinking about here. If someone says equal concentrations of equal volumes, that means equal moles. So I'm looking for, in this situation, to know what volume of the 0.25 is needed to get to match the moles. The moles are equal. So let's do that over here. So I'm going to find the moles of the sodium nitrate. So it's molarity times liters equals moles. So it's going to be 0.5 times 0.1 liters is going to be 0.05 moles. Okay, that's how many moles are present here, 0.05 moles. Now I'm going to need 0.05 moles to match at a 1-to-1 ratio. So let's do it again here. Molarity times moles per liter, and I want liters. So it's going to be moles per liter equals mole. So it's going to be equals moles per liter. So I'm going to moles per molarity equals liters. So now I have my moles of 0.05, and my molarity is at this 0.25. And what do I get? Okay, so 0.05 divided by 0.25 equals 0.2. Okay, so my answer here is 0.2 moles per liter. Sorry, liters. 0.2 liters. Now here's my question. Could I have gotten that without doing all that work? The answer is yes. So molarity in moles and liters equals moles. So I'm going in a 1-to-1 ratio. So I have twice the concentration. Okay, so I have half the concentration. So I need 2 times the volume to match that. If this goes down by 1/2, this needs to go up by 2 to match it. So 100 times 2 is 200, which is what this is, 200 milliliters. Always looking for proportions if we can. At this point, what's the concentration of each ion in solution? Okay, so in this situation, it wants us to draw a picture of it anyway, so let's draw it out here. I'm going to have some silver chloride on the bottom here, AgCl. I'll have some sodium ions floating around and some nitrate ions floating around. Okay, and they want to know what is the concentration of each ion. Alright, so I'm going to do this here. I'm going to do a sort of a before and after type situation. I have the NaCl, and I have the AgNO3. This is 0.5 and this is 0.25. Okay, And these are the two things that I have. And I want to know the stuff floating around in solution. Only thing floating around in solution is NAs and the NO3 minuses. This guy is 0.5 before, because you take your concentration times 1 is 0.5, and this is 0.25 times 1 is 0.25. Okay, and then I'm going to simply, these guys aren't reacting, so I'm just going to be diluting them in half. Okay, now I shouldn't say that. I'm going to dilute them, but I'm not going in half. I'm going from 100 plus 200 to 300. So to do this problem, you could do it a couple ways. You could just do simply molar equals moles per liter, and that's easy enough. I'll do that with the Na. My moles originally is 0.05. That's how many chlorides I have, or NAs I have, both 0.05. So 0.05 divided by 0.3 liters is my concentration. Same moles, new volume. 0.05 divided by 0.3 equals 0.166. 0.166 liters, moles per liter. The other version, because I'm not adding any new stuff in, it's a dilution. M1V1 equals M2V2. Initial concentration of the silver is 0.25. Initial volume, 200 milliliters. And ending volume, 300 milliliters. Give us more room there. So 0.25 times 200 divided by 300 is what? 0.25 times 200 divided by 300 equals 0.166. And this is 0.166, which is the same as the other one. Is that a coincidence? We'll look at our drawings. We have one of these guys for every one of these. They have to be the same. The charges have to balance. All right, let's write out a net ionic equation and draw a picture. So really all we got to do here is net ionic is Ag plus Cl minus yields AgCl. So the sodiums and the nitrates had nothing to do with the process, so they just floated around. Eventually got diluted out. All right, next question. Okay, here's a practice question here. When 30 milliliters of 0.1 molar silver nitrate is added to 30 milliliters of 0.1 molar sodium chloride, aqueous sodium nitrate and solid silver chloride are formed. How much silver chloride is produced? Take a moment, pause it, try it. Okay, so note here that I have the same equation, Ag plus Cl minus yields AgCl. It will be 1 to 1. So whatever moles of this stuff I have is equal to the moles of their stuff, which of course is. So there's no limiting reactant. Both will run out at once. Okay, so it's just going to be molarity equals moles per liter. And they want this to be in moles, so it's just molarity times liters equals moles. And either one you could use. 0.1 times 0.03 liters is 0.003, and therefore this is the amount of moles of either reactant, and that would also equal your amount of product, because it's a 1 to 1 or 1 to 1. Both of these guys would be the limiting reactants. All right. Next one. Alright, so we have a chemical reaction here where we have two things reacting. But we need to balance this thing. We need to have a 2 right here. And that's going to give me, no, I think that's good right there. Going to be 2 waters, I think. There we go. Alright, so we're mixing two things together. 100 milliliters of 0.5 molar of this stuff. Actually, 100 milliliters of 0.5 molar of this stuff. So you note that we have equal volumes of equal concentrations, so these have the same number of moles. But this guy's used up twice as fast. So this is my limiting reactant. In fact, the chloride's going to be a spectator, just floating around. It's aqueous So the hydrogen actually is the limiting, what I call limiting ion. It's one that's going to eliminate from the solution and will stop the process. At this point, what's the concentration of each ion? Who's limiting? It's going to be the HCl. So what's the concentration, I'm assuming beforehand? So before and maybe after. Okay, let's try it out. Before, it's going to be, so we have the calcium, we have the hydroxide, we have the hydrogen, and we have the chloride. Before, all we do is multiply out. 0.5 times 1 is 0.5. 0.5 times 2 is 1. 0.5 times 1 and 1 is just 0.5 and 0.5. Now, run them down to nothing. Okay, so this is going to use just straight proportions here. All right. We double our volumes from 100 to 200, so the spectators just get diluted. So that would be the calcium and the chlorine. They're just going to be diluted. Doubling our volume cuts our concentrations in half. 0.25 and 0.25. The hydrogen, as I mentioned, is going to go to 0. Okay. Now the hydroxide, I'm going to use up half of it. The hydrogens will knock out half of the hydroxides, which will knock it down to 0.5. Then we double our volume, which also knocks down again to 0.25. This is our ending concentrations. Okay. You'll notice here that we have, well, either way, let's move along here. So let's draw it out here. So it would be something like this. I have calcium plus 2, OH negative, OH negative. And I have I'm going to draw out, if I have equal moles of these things, so if I draw one of each, it would be H plus Cl minus. And at that point, we would just simply have the H and the OH grab each other. This guy grabs that guy, forms a water, and then there's things just sort of hang out. I have my calcium is still there, my chloride's still there, my hydroxide, excess hydroxide still there. Notice that half of my hydroxide's gone, and that's it. Okay, that ionic is going to be calcium hydroxide plus H plus goes to calcium plus 2 plus H2O. There's maybe a few different ways you could do this, but that one's the best, I think. All right. Got ourselves a question here. Okay, reaction 2. This reaction requires excess 6 molar hydrochloric acid. Okay, 6 molar. To 100 milliliters of this of unknown concentration. If the reaction goes to completion, 0.1 moles of chlorine is produced. 0.01. What's the molarity of this of the original solution? Pause out for a moment, give it a try, see what you think. This could be a nice table problem. Alright. There's the answer, and there's the reasoning. Okay. So, just worked backwards. All these moles used to be there. If we got 0.01 of this, then I had 0.01 of this. And if it's in that volume, then trying to divide the original moles by the original volume gives my original concentration. That's an interesting problem. Oops. All right, and we'll end our basic solutions problem here. I got a bunch of stuff there, but we will take a later video here and walk through more slowly a bunch of problems out of your workbook. So thank you very much.